if we can get the clicker working. All right, awesome. Thank you all for coming out to see me so early in the morning on the third day. Before we tuck into nitty and gritty of performance stuff, I want to kind of give a frame of reference for this talk. Yes, we will be seeing a lot of code, and I will be talking about a lot of rather technical things. But ultimately, this talk is about design. I love this quote from Jeff Bean. I've been amazed how often people outside the discipline of design assume that what designers do is decoration, likely because so much bad design simply is decoration. Good design isn't. Good design is problem solving. In terms of designing user experiences, the problem we're often charged with solving is how to help users accomplish a task, right? In most cases, we want to do as much as we can to remove any obstacles that get in their way, friction. This is probably like the 48th time you've heard the term friction during the course of this conference. And that's because our job is to remove friction from people trying to accomplish tasks, or at least reduce it, trying to make it as painless as possible for people to do what they need to do. Now, I don't think many of you would argue with me that some of the hallmarks of good UX are a streamlined flow to accomplishing a task, clear, concise copy, which Christina, I'm sure, would be very happy to hear, low cognitive load, so not too much to deal with, which becomes exceptionally challenging when you end up in a headless UI or a voice-based experience. When you can't see anything, cognitive load becomes a really big deal. And then finally, fast performance. And there are a ton of other hallmarks as well, but these are the ones I wanted to touch on today. Back in March of 2012, Apple announced the Retina iPad. I don't know how many of you remember this. And it had this high-resolution Retina display. Everybody was very excited about it. And I was staying at a hotel at the time, oddly, in Silicon Valley. And I decided to head over to apple.com to check it out. And I ran into a little bit of an issue. It took 30 minutes to load this page. Literally 30 minutes. I am not exaggerating here. And it wasn't a delay due to the server being overwhelmed. Even the hotel Wi-Fi wasn't really to blame. The problem was that Apple was sending high-resolution images to every device. So they were sending those Retina images and then putting them at half the actual inherent dimensions of the image in order to have that crispness of display. But this was in the days before we had responsive images, so they were sending these to absolutely every device. If you were on a mobile device, you were downloading that same thing. And if you were on a pay-per-bit connection, dear Lord, I don't even want to know how much that would have cost you. We need to be concerned about the performance of our web pages because poor performance is friction. That could be certainly a lost sale for somebody at Apple that they decide, they don't care about me. Why should I buy their product? And I'm sure you've seen countless studies that have shown time and time again that speedy performance is key to website success. It matters. So the Harris poll found that speed was the second most important attribute to a website, ranked right behind easy navigation. And oddly, right ahead of reliability. So in other words, people would rather something be fast than it actually work all the time. According to data from Akamai and Gomez, Kissmetrics determined that a 1-second delay can reduce conversions by about 7%. To translate that into something that might be a little bit more tangible, for an online shop that earns about $100,000 a day, that's about 2.5 million in lost sales. Of course, that's a little bit hypothetical. Amazon actually knows what it costs. So for Amazon, 1 second of delay is worth about $1.6 billion in sales. So web performance, kind of an important thing. And Mobiquity found that slow mobile load times was actually the greatest source of frustration for mobile shoppers. In Una's talk, she mentioned this stat from Google where they've discovered that 53% of people abandon websites that take more than 3 seconds to load. But rather than focusing on negative, let's switch it around and talk about positives. So by shaving 7 seconds off of load, Edmunds.com actually increased page views by 17% and ad revenue by 3%, which is pretty awesome. And from a slightly different perspective, Mozilla actually found by taking 2.2 seconds off of their load time, they increased downloads by 15.4%, which is pretty impressive. So should be no surprise that performance really matters at this point. and this was one of the things that we took into account when we decided to revisit the 10K apart contest, which we ran last year. If you're not familiar with what the contest is, it actually originated as what was called the 5K, which was created by Stuart Butterfield of Slack and Flickr fame, where he challenged people to build a site in 5K or less. This was back in 2000. Excuse me. And in 2010, it returned under the guidance of an event apart and Microsoft, and then it returned again in 2011 and focused on responsive design. But what we were starting to see as we looked at the different entries that were being submitted, especially in that 2011 one, was that a lot of them were really JavaScript heavy. And there was a reason for that. The rules were such that you had to submit your site as a zip file. There was no server side or anything like that. So you had to deliver a 10K or smaller zip file, and that was your entry. We decided, looking back at this as something to have it to celebrate the 10th anniversary of an event apart, we wanted to switch things up and maybe take a new look at how that was working. We opened up the idea of having back-end opportunities in order to be able to help us focus on things like performance. So we decided to switch things up a bit, and we were looking for a usable page to be delivered in 10K or less. So per page load, not talking about the overall size of the project. But still, 10K is tiny, right? This is not a lot to work with. We also wanted pages that were accessible. Accessibility is so crucial, so we decided to bake that into the contest as well. And that meant not just screen readers, but things like keyboards, alternate input types, and that sort of thing. And we got some really fantastic entries. We wanted them to follow the concept of, or the philosophy of progressive enhancement, which if any of you have seen me speak before is probably what you saw me speak on. So thinking about how we can make our sites improve as the capabilities of our users and their devices improve. And then we required that users be able to do what they needed to do without JavaScript access at all. And this wasn't because JavaScript's a bad thing. It was simply because the reality is that you're not always guaranteed that your JavaScript is going to run. There are a ton of things that can cause JavaScript execution to stop, and you don't want your product to just die, right? You don't want it to be unusable. And ultimately, many of these aspects were focused on the user experience overall, but also on improving the performance and the page load of a site. So when it came to building the actual contest site, I decided that we would challenge the team that was building it to actually eat our own dog food, so to speak. So we actually built the site to abide by the same rules as the contest itself, to have it out there as, here's an example of how you can achieve this sort of thing. So before I get into some of the optimizations that we did on the site to improve performance, I want to give you a quick overview of how pages load, just so that we can kind of level set and make sure that everybody kind of understands, because there's a lot of implications to how web pages get delivered to us in a browser and how the browser processes those. This isn't going to be exhaustive. I'm going to kind of do treetops, but just to kind of give you an overview of how things work. So the first step is you typing an address into the address bar or following a link, right? So first thing that needs to happen is what's called the DNS lookup. So we need to figure out, let's say you're going to an eventapart.com, we need to figure out where an eventapart.com lives. So we make a request for that DNS information. It could be stored locally on your computer. You do have a local DNS cache. Sometimes routers store that information, so you might have it on your local network or your provider's network. So it may not have to go far to get this information. But eventually, you may even have to go all the way out to the DNS server for that specific site. But eventually, you get a response that says, hey, it's at this IP address. Okay, this is where you need to go in order to find that. So then the browser makes a request, or basically says hello to that server. It does a little TCP handshake, is what we call it. And hopefully, the server responds. And that kind of kicks off the process, right? We know where we're going. We know we're communicating with the right person, or with the right server. Then we make our request. I'd like to see the index HTML file, right? Then the server does some processing on its end. This can vary widely in terms of how long it takes to complete the thing. If it's doing a lot of database lookups and stuff like that, that could take a while. There are performance optimizations you can do on the server side certainly as well, and I recommend that you do. They're beyond the scope of this talk. But then eventually, the server spits back a response, and then the browser actually has to do some work. So most of this takes place pretty quickly, especially if you're on a good network and your server is pretty speedy. But once the browser gets it, it's got its whole process for actually building that web page and rendering it for the user. So this is the kind of the steps between getting the response and actually having the page fully loaded. So the first thing that happens is that the browser reads the HTML, and I'll kind of walk through how that works in a few minutes, to build out the DOM, or the document object model. It then parses the CSS and creates the CSS object model. It then sort of weds those two things in order to build out what's called a render tree. And from that render tree, it's able to determine what the layout is and how it needs to place all of these elements on the page. And then finally, it does the paint. Okay. Now, this seems like a fairly straightforward thing, but what ends up happening is that CSS and JavaScript, as they're encountered in the document, can actually cause certain portions of this to have to rerun. So it causes delays and repaints and reflows and all of that fun stuff. So to kind of illustrate that, walking through a bit of HTML here, this is just a contrived document, but to illustrate, starts parsing through, gets to a script file, and then it has to call out to that script file and parse that script file, see if it's affecting the DOM or affecting the CSS. In other words, having implications for the render tree, layout, and paint. Same thing has to be done for the CSS file when it gets to that. Inline stuff is great. It can just kind of move on, chug through, process what it needs to. It'll hit that image request. The image won't delay anything. It'll just kind of put that in the queue for downloading. And then it hits that last script at the end there, and it has to wait while it gets that and then determine if that JavaScript is going to have any impact on the layout as well. And then it can finish processing the document. So there's lots of things that can kind of impact how the page actually renders in the browser when we're trying to load it for a user, and all of that affects the performance. So I'm going to walk through, I think it's 6 steps. There are a lot more optimizations that we did on the site, and I highly recommend checking it out. It's at a-k-apart.com. You can dissect it at your whim. But the 6 steps that I want to walk through today are, we should look to use native features whenever possible. Right? We want to rely as little on additional dependencies as we can. We should only include the assets that we actually need. We should optimize everything. That's kind of a no-brainer. We should think about when we load assets, so what part in the process we load in different assets. And then we should consider how we load those assets. And then finally, we should only load assets that actually add value. So again, this kind of comes back to that you should only include assets you actually need, but sometimes you need to have that conversation again with people on your team that, oh, you know, what you thought we needed is actually not really adding that much value, and there's some other ways that we might be able to tackle it. So, so these are the steps I'm going to walk through today. So step 1, using native features whenever possible. Native features are awesome because they are free. They come to us free in the browser. The browser takes care of a lot of different things for us, and it's awesome. So for example, if you've got a header for your site, rather than having div with an ID of header, use the header element from HTML5. It's shorter than div ID header, so it's less to send over the wire, certainly. It's more semantic. And it also creates a landmark, depending on its location in the document. It creates a landmark to provide easy navigation to people who are using assistive technology. So it has an inherent role that it gets for ARIA, the Accessible Rich Internet Application Spec. A little bit more complicated example. Here's an input for the person's name that was for the submission form for the site. And we've got a lot of stuff going on in here. So first of all, there's the required attribute. This informs the browser that, hey, don't submit this form unless this field is filled out. There's ARIA required, which is the parallel to inform assistive technology. There's a lot of reasons that ARIA required doesn't automatically get mapped from required, but I won't get into all that. We can tell a browser, don't try and autocomplete somebody's name. Right? That might be a frustrating thing for someone. We could do a placeholder. So in this case, Sir Tim Berners-Lee, and that's auto-disappearing, and it's a suggestion. And we don't have to have any JavaScript to do that, right? How many folks in the room have written JavaScript to add and remove placeholder text in the past? A couple? Yeah, I think a lot of us have. This is free, and it's easy. It's one attribute. And then this one's actually super fun. The autocomplete, this used to just take on or off, or non-existent or off. But now we can actually use keywords to indicate what it is that we want. And if the browser has that information, it can basically prompt the user, hey, do you want to fill in the information we already have for this field? So it makes it a lot easier. It takes the friction out of entering your information. Jason Grigsby, who spoke yesterday, has a fantastic article all about the autocomplete attribute and a bunch of other stuff on the Cloud4 blog. I highly recommend checking it out because it's a super powerful tool. To go to a slightly different example, this was the email field from that same submission form. Simply using type equals email will make modern browsers validate that email address for you, no JavaScript required. And any sort of virtual keyboard is actually going to provide, or most virtual keyboards, I should say, because I have seen a virtual T9 keyboard, which is, ugh. But most virtual keyboards will actually give you a custom layout to enable somebody to input email addresses more quickly. So with the @ symbol, the dot, it does include a space because the email field can technically take multiple space-separated email addresses. In this case, we've got autocomplete email for the keyword down there. So if the user has an email stored in their browser, it can prompt and automatically fill that in. All, again, without involving JavaScript. Lots of free stuff, right? I don't think anybody would argue things like Flex and Grid are a heck of a lot better than dealing with the massive amount of CSS we need to create float-based layouts. And we don't have to involve JavaScript to do gritty type things. Just makes it much simpler and much smaller. And similarly, we don't need JavaScript libraries to enable us to do things like CSS selector-based DOM selection. So we have things like query selector and query selector all that let us do basically what the jQuery function did, right? Lets us select all of those. Similarly, we should look to creating more robust font stacks that actually take advantage of system fonts. So these were the font stacks that we put together for the 10K Apart site. These all use things that may be available. And if we were to actually look at them in comparison to one another, we tried to choose fonts that were pretty close in terms of size so that we didn't end up with weird layout issues or weird renderings if one of the fallback fonts needed to be used. Okay. I think font stacks are one of the things that we really haven't explored as far as we can go with them. I think there's a lot we can do with that stuff and coming up with neat things. If you do need to use a custom font, subset it. In most cases, this is the right choice. Remove as many of the characters as you will not need as possible, but don't go overboard. First of all, there are command line tools. There's Font Squirrel, Typekit, the Google Font Services. They all support subsetting, so it's a fairly easy thing to do now. But you don't want to end up in a situation like this, where, yeah, they didn't include the U with the umlaut. That looks pretty bad. Step 2, only include the assets you actually need. So there are a lot of great libraries and frameworks and stuff like that out there, but honestly, for most sites, they're probably overkill, right? Your blog probably doesn't need to be a React site, honestly. If you want to experiment with React, that's fine, but it's probably overkill for a blog. And every tool that we choose has a cost to it, right? So if you were to use Foundation, for instance, instead of Bootstrap, all up, that's about 266 kilobytes, or a relatively large image worth of code, right? And chances are you're only using a small portion of it, right? Some of these libraries and frameworks do allow you to basically do the same thing as font subsetting, where you can take only the bits and pieces that you actually want or need, and that's great. But a lot of times that's not what people do. In fact, a colleague of mine went to a major retailer to help consult on their JavaScript performance. And what he found when he actually popped the hood on the site is they were loading 3.5 megs of JavaScript because they had jQuery, Prototype, Scriptaculous, MooTools, and umpteen other things, probably EXTJS, given what time it was. Basically, every developer who was touching that JavaScript code was either pulling in the library that they liked or was Googling for a solution and found one that required a library, and they're like, oh, well, I need this solution, so I need this library too. And feeling like it was free, right? But it's not. That's a lot of weight. And so he went in and basically eradicated all of that JavaScript. And like, wow, the site's so much faster. Of course, it was 3.5 megs of JavaScript. Now, a lot of folks who do use libraries bank on the fact that there's a CDN that's hosting that library for them. So they get some performance improvements from that because there's a possibility that that user may already have that version of jQuery or that version of Bootstrap or what have you already on their computer from another site. And so the cache can be used instead. That can be great as long as there's not a network issue with the CDN, or let's say a provider decides to block that CDN because it thinks it's malware or something like that. But you still incur some additional overhead in making that connection in the networking realm as well. It has to spin up that connection. It has to do the DNS lookup, the TCP handshake, all of that sort of stuff if it doesn't already have that file in the cache. And that can cost some serious time, especially on high latency mobile networks. So it has to go through this whole process for each CDN domain, right, potentially. And the more CDN shards you have, the more lookups it has to do. And again, on mobile, that just drives down performance. Thankfully, we can optimize these a little bit using hints. So we can do a lookup of the server early. We can say we want to prefetch this DNS request and just give the top-level domain that we want it to prefetch. And we put this, you would put this link in the head of your document. We can also actually cache all the way, or not cache, but we can preload all the stuff up through the TCP handshake, which we do with the pre-connect. So we initialize that connection, and this lets the browser optimize when that happens. So if it's got any idle time, it can go ahead and do that in the background. And we can even optimize the request for particular assets by using the preload. And there are a bunch of other resource hints that you can use as well. The as attribute here tells the browser what it is that you're loading. So we're loading this as a script, so the browser knows how to treat that in terms of the optimization of the loading process as well. Still, download isn't everything. Once the file is actually retrieved from the server, it actually needs to be parsed and executed. A couple of years ago, the Filament group did a test where they built the exact same, I think it was a to-do app, and in a bunch of different frameworks that were popular at the time, and tested them on a wired connection, on a 3G connection on a desktop, sorry, a wired desktop, 3G desktop, and then 3G on a mobile phone, and looked at how long it took to get to an interactive page in loading up all these libraries. So Ember 1.9, which was the then current version, took almost 5 seconds to load on 3G and mobile. And the reason for that was not just that it was a large library to download, but the device itself had a much slower processor than a desktop device. And so it took a much longer time to actually kind of crank up that script and get it to actually run, to get that framework to run. So the performance was much worse. And even if you have the library downloaded and executed and stuff, libraries are actually quicker than native code, or sorry, slower than native code. So if you were to look for an element by its ID, using document.getElementById, which is the vanilla JavaScript way to do it, you could actually do 12 million of those in a second. jQuery's lookup, if you were to supply an ID as the CSS selector in the jQuery function, can only do about 350,000 of those. So it's like, what did I write? It was like it's 98% slower. That's pretty significant. That can have a real impact on the overall performance of your website in terms of the interactivity and such. So when we were building the 10K apart site, we decided, you know what, we're going to go 100% library free. The 10K apart used to allow you to use jQuery for free, used to allow you to use Typekit for free as well. We took out all of that and said, you know what, let's just focus on the core stuff, right? We did borrow one function from Modernizer, which was they have a really good SVG test that we incorporated into our thing. So because it's MIT licensed, we were able to extract that with credit, of course, and include that in the code that we were running. And we also used resource hints. So we made some pre-connections to the site was hosted on Microsoft Azure. So we made some pre-connections to the Windows blocks, to Cloudflare, which was handling some stuff for us, and Google Analytics as well, just to kind of optimize that stuff. All right, step 3, optimize everything. So this is going to be a lot of numbers, and I apologize for that. A lot of steps, rather, that we went through. But I wanted to kind of to actually give you a down to the metal overview of how we optimized our CSS and our JavaScript. So I apologize, a lot of bullets. We used Gulp to be our task runner to do all of this stuff. The original CSS was all written in Sass using the SCSS format, and we used Breakup, which is a nice tool for managing media queries. Highly recommend that if you are in the Sass space. We would compile our CSS with a decimal precision of 4 in the Gulp Sass task. That seemed to do pretty good in terms of rounding of layout stuff. We then used Auto-Prefixer to create fallbacks for the modern CSS for any browser versions that were up to 2 old. Then we would go through, and if in coding the CSS I'd made a mistake and I could have optimized something by using a shorthand property instead of multiple longhand properties, we used Gulp shorthand to actually automate the creation of those shorthand properties just to compress our CSS just a little bit more. We also removed any unused declarations using Gulp uncss. So if there was anything that maybe we had done a slight design shift and I'd forgotten to remove a rule, we could do that. There was some tuning that was needed in that process to accommodate things that were being injected dynamically via JavaScript. So you have to inform it of things that it's not able to just render the page and know is in the HTML, because it scans all your HTML documents. We would then optimize the files using CSSO, minify them using clean CSS, and then we actually pre-gzipped, so did the gzip compression when we were building out the files, and we also did Brotli compression, which is even better than gzip, when we were building the CSS files. And the reason we did this is because it's less overhead on the server if it just has to serve a pre-compressed file, rather than having to compress it on the fly. So again, just thinking, how can we squeeze as much as possible out of this? So we ended up, this was kind of the overall structure to the CSS. We had everything very modular. And then when we actually went to build it out, this is what we ended up with. So we have, just kind of pointing to the, I'll talk about the different CSS files in a few minutes, but for the advanced CSS file, the browsers that could handle Brotli compression had a 2K file. Browsers that could only handle gzip got a 3K file. And if it couldn't handle either of those, it would get an 8K file. So that's a pretty significant savings, 1/4 the size for browsers that had Brotli compression support. We did a similar thing with JavaScript. It wasn't quite as involved and convoluted because a lot of the tools are kind of bundled together for doing this sort of stuff. So we wrote our JavaScript very modularly as well, grouped as appropriate, and I'll walk through the organizational process in a second. We then combined files based on folder structure, which again you'll see in a moment, using Gulp folders and concat. We then created a wrapping closure to isolate the different JavaScript things from each other so they didn't bleed into the global namespace. Minified using uglify, gzipped, and then did the Brotli compression. So same sort of thing. So for our main JavaScript file, we had a folder called main, and then inside of that we had all of the different modules that went into the creation of what was effectively our library for the site, which was about 8K all up. When it was compressed, we ended up with 1K for the Brotli version, 2K for the gzip version, and 4K for the normal minified version for browsers that didn't support compression. So pretty sizable savings as well. Now, Anyone who's got kind of eagle eyes might be wondering why the heck I have, if I can get it, there we go, why the heck I have this omega down here. So interesting note, if you want to actually be able to control how the concatenation runs, it runs alphabetically. So we did underscore for the first one, so it would always index first in the alphabetization, and then omega would always come last. So if we needed to have some sort of header and footer effectively for a given JavaScript file, we could do that. We also actually minified and pre-compressed our HTML. And then this was a Node app, so we let Node just serve that and do any variable swapping it needed to do using those pre-compressed files, which was pretty cool. Again, all about saving server-side time, and then we also used Varnish to cache things locally on the server as well once we had pre-rendered output. So yeah, lots of server-side optimizations as well as client-side ones. The next step is to think about when we load assets. So in total, we had 10 JavaScript files that could be loaded into the site as a whole in various scenarios. So the main.js file was the site's library. We had a service worker as well because this was also a PWA. We then had one browser-specific file. So we used the HTML5 shiv for any versions of IE that were less than IE9 because they wouldn't know how to handle those new HTML5 elements. We want to at least be able to give them a good layout. So we used the HTML5 shiv delivered just for that, and I'll show you how we did that in a moment. And then we had a bunch of page or function-specific JavaScript files that would only be called in on a specific page or might be shared by 2 pages or so on the site. So enter.js was for the entry form. The form saver.js we actually used on the entry form, and then there was another one for the update form for the winners so that they could put in their addresses so we could send them things. So we shared that between the two, which is why it wasn't on the enter.js file. Hero.js ran the SVG animation, which I'll show you in a few minutes. Home handled the home page. Project handled the project page. And then the update.js handled the address update page for the winners. And per the common wisdom, main.js file at the end of the document. And then we would add in any additional page-specific files after that. And so home min.js, we would go ahead and load that with defer. And what defer says is run this after the DOM has loaded. Okay, so it's a way of telling the browser, hey, don't stop your DOM parsing. Keep on in that rendering process. Don't let me hold you up. I'm just going to go ahead and defer loading on this one. Another option is async, and the difference between them is that async says run whenever this file becomes available, but don't block the loading of the page. Okay, so they're slightly different. Now, it's tempting to say, you know what, I'm going to defer or async all of my JavaScript because I don't want any of it to block anything. So I'll just add async on both of these. Awesome, no problem. Well, what happens if the second file calls a function in the first one, but because they're being asynchronously loaded, it gets loaded first? Well, then all of a sudden we have what's called a race condition, and we don't have access to the function that we wanted to have access to or expected to have access to. We don't want to do that because it can cause the browser to throw errors for our users, which is poor user experience. So instead, we would just asynchronously load any additional JavaScript files and keep the main one loading in the normal blocking pattern. But at least it's at the end, so most of the document, the DOM, would have been built out. So why so many separate files? Well, the JavaScript wasn't needed on every page. Not every bit of that JavaScript really needed to be in the main library. There may be people who come to visit the site that never go to the entry form, right? And the entry form is only going to exist for a short amount of time, so why would I load that entry form JavaScript into the main.js file? Same thing goes for the winner update. Only 7 people were going to actually hit that page, so there's no reason to load that into the main library. Same sort of thing with additional pieces that might be a feature-based thing. So the SVG had its own animation stuff, and the SVG, which you'll see in a minute, was done by Sarah Drasner. But that JavaScript didn't need to be loaded unless the SVG was loaded. And if the browser didn't have SVG support, it didn't make any sense to have that included in the main library. So we decided to just keep them as separate files. Now, in HTTP 1, which is kind of the old way of connecting and retrieving documents, browsers had limits on how many connections could be made simultaneously to a given domain, or how many overall connections could be made. And these were all done in parallel. And we also had to deal with something called head-of-line blocking, which meant that a resource had to be completed, the download of it had to be completed before another one could be kicked off, which caused slowness. So HTTP2 came along and actually gives us sort of a single pipe to send all of our stuff through in a stream, and things can kind of load as they need to. All of your requests can be kicked off, and stuff just kind of flows in, which is awesome. If you're someone who spends time in dev tools, and the waterfall is something that you're familiar with looking at, it basically takes you from the top version, where one thing loads after another, to wham, everything comes in kind of at once. On its own time, but everything comes in at once, using one TCP connection. So to give an example of this, Akamai actually put together a comparison of HTTP 1 and HTTP 2. So this is an example of loading 379 individual tiles for this image. And you could see how much faster all of that data flowed in on the right-hand side, the HTTP 2 version. So it didn't matter that there were 379 different files. It was still faster. And actually, Stefan Baumgartner put together a great post for a list apart that kind of revisits the common wisdom of the best request is no request, which was all about embedding everything that you could into your file, and revisits that with HTTP 2 in mind. And if you're interested in that, I highly recommend reading it. It gets into a lot of detail and a lot of stats around improved performance with HTTP 2. We also need to consider how we load assets, not just when. So one step that we took in terms of optimization of this site was to actually have two separate CSS files. One that was sort of our default styles that would be delivered to all browsers, regardless of capability. And this file was tiny. And then we had a second CSS file that was advanced styles that we only wanted to deliver to modern browsers. And what we did is we used fault tolerance, which is an inherent characteristic of CSS, to enable us to manage that delivery. So by adding media equals only screen, the only keyword, which is part of media queries, is not understood by browsers that don't support media queries. So they would just ignore this CSS file entirely. So if somebody, I don't know, happened to come on IE 6, 7, or 8, they would only get the default single column layout, mobile layout, since we built it all mobile first, which is, again, another efficient way to build things. And that was fine with me. If IE8 got a single column view, they can still do everything they need to do. It's just not laid out as nicely, right, on a wide screen. So that's kind of a fun way to manage what you need to do. I mentioned the HTML5 shiv. We used conditional comments, which aren't supported in Edge and newer versions of IE, post IE 10. But older versions of IE did support them. So if we said if less than IE 9, which is that weird comment bit at the beginning, this JavaScript file would actually be loaded in IE 8, IE 7, IE 6, but not in anything modern. And all other browsers that aren't of the Microsoft vein would ignore this entirely as well, as would Edge. We also used conditional comments in the inverse way around our scripts. So this is a way of using conditional comments to hide things from certain browsers that support conditional comments, so IE8 and below in this case. So if the browser is greater than IE8, basically close this comment out and show everything that's inside. But if the browser is IE8 and below, then it ignores this entirely, which is great because since I know my site works without JavaScript as well, I don't have to bother testing that the JavaScript-based functionality works in IE8, right? Even if I happen to have that browser. I'm not optimizing for IE8. I'm not spending a long time worrying about it. I'm just saying, you know what? It doesn't need the JavaScript. It's OK, right? It can have that default layout, and it can have no JavaScript, and I'm good with that. You can also load images conditionally. So we did this in the footer. On the small screen, we don't include the Microsoft Edge and an event apart logos. But as we move up to a larger breakpoint, in this case a minimum width of 36.375 ems, I used generated content to inject the Edge PNG or the SVG if the browser supported that. So the SVG being the optimal small file. So browsers that support SVG, interestingly enough, also support multiple background images. Browsers that don't. So browsers that don't support multiple background images would ignore the second background image rule, but modern browsers would see it and override the ping value. We also lazy loaded the SVG animation that Sarah Drasner did for us on the homepage. And it had its own JavaScript. It was interactive. The SVG, actually, for all of the interactivity and complexity of it, is actually under 10K itself, which is pretty awesome. Sarah did some amazing work for us on that. And I'm actually just going to walk you through using an IX map, which is an interface experience map. I do this a lot when I'm trying to come up with different ways that people might experience a site. I find it to be a handy tool. So on page load, we have the question of whether or not JavaScript is supported. Because we're going to lazy load this in, that will require JavaScript. So if there's no JavaScript, we won't load that image in. And I'm OK with that. Right? That is taking performance first, right? Because it's going to be an extra 10K to download and an extra request. Right? If we do have JavaScript, however, we can verify that we're actually in a width where it makes sense to load that graphic. Right? Because we may not have that much room. So it may not be worth it in the long run to pull it in. So in that case, we could still default to having no image. If that condition is met, we can test to see whether SVG is even supported. If SVG is not supported, rather, we could load in a picture element that maybe has an optimized PNG or a GIF version of it that's not animated or interactive, if we just want to have that. But if it does have CSS or SVG support, rather, we can make an AJAX request for that SVG, yank out the script element, and dynamically add it to the document, which will cause it to be downloaded and run, and then inject the SVG into it. And as an extra optimization, let's cache the result of this in local storage, and then we'll just pull it back, and we don't have to run all of this extra code again if we've already run it once for the user. So once they've visited the homepage, if they've downloaded that SVG file, we've already got the full markup and everything in the cache, basically, locally to inject in there instead of having to do all that process again. Step 6, only load the assets when they actually add value. So images can be great. They're really useful for drawing your eye if you're dealing with a page where competition is high, like a home page, especially if you're a news organization or something. But they become less useful when competition is low, like on a small screen. Now, when evaluating images, and I know Una talked a lot about this yesterday, and I'll kind of reiterate some of the stuff that she said, but what's really important is deciding whether or not you need the image in the first place, right? Does the image reiterate information that can already be found in the surrounding text? Because if it does, then it may not be as useful. Is the image necessary to understand the surrounding content? Does the image contain text, in which case that should probably be text, frankly. Is the image a graph, chart, or table, in which case it's probably useful? Could the content of the image be presented in a different format that wouldn't require an image? Right? Again, that gets back to the text one, but there's also a lot of other situations where that comes in. And then lastly, is the image purely presentational? All important things to consider. And that's because 53% of the average web page is images. Right? And they don't always work with the layouts that we have. Right? You can end up with them completely ruining the reading experience for a user because of the way that we end up flowing them in. The truth is that not every article needs a picture. I highly recommend, there was an article in the Outline not too long ago. And it's interesting, especially because it comes from a non-tech perspective. It's just a journalist kind of talking about this. And the distillation, if you don't want to read it, is if you're writing an article about cybersecurity, I really don't need to see a stock photo of some supposed hacker, right? Unless it adds real value, leave it out, right? If you can avoid using an image, do it. We should have to justify each and every image that we incorporate into our documents. If you do need to use an image, choose the best format. And Una went into great depths on this of a bunch of the different formats. I'm just going to hit treetops on these just to kind of refresh. So GIF, GIF, whatever you want to call them. I call them GIFs. For images with large swaths of solid color, that's what you want to use. It's going to be really tiny. You're only going to get binary transparency, so either a transparent thing or it's not transparent, right? For JPEGs, these are great for photographs or images with gradations of color. They can be compressed, but you get those janky artifacts, right? 8-bit PNGs, very much like a GIF. They can support alpha transparency if you use the right software. So Fireworks, that was actually one of its best features, I thought, was you could do alpha transparency in an 8-bit PNG. 24-bit pings were come up with as an alternative to the JPEG. They're usually larger, but they do support alpha transparency. And the final one I'm going to talk about is just WebP, which is a newer format, as Una mentioned, not universally supported. It is smaller than JPEGs and 24-bit pings. Supports alpha transparency, support animations, and a whole bunch of other awesome things. Now, there are instances where images are nice to have. They're not necessary, but they can add a little flavor. So maybe they could bring a little bit of value to a particular interface, but they're not necessary for people to be able to do what they need to do. So one example of that is the judges for the 10K apart contest, right? This was 29K of images, which is actually pretty tiny considering it's 5 photographs, 6 photographs. That's pretty tiny. But the default experience we chose to go with was, hey, no images. And that's OK. You still see the people's names. It's still usable. You can still link through to their Twitter profiles. But then if we feel like we want to load in the image in certain scenarios, we can do that using JavaScript. And in order to make the JavaScript smaller, we had it informed by markup. So we used a data attribute that included the source of the image, an alt attribute if we felt like we needed one, which in this case, it would just be reiterating the name of the person. So that was kind of redundant and unnecessary for assistive technology. And then we would say whether or not to prepend it, because we use this in a variety of scenarios throughout the site. There were a couple of other API options that followed after this that had defaults that I didn't use in this scenario. But this was the basic API. And don't worry about understanding this JavaScript here, but I'm just going to kind of walk you through what it does. On the JavaScript end, we're generating a div that's hidden and giving it an ID of getActiveMQWatcher. So we're going to use this as a way to get our CSS and our JavaScript in sync about what breakpoint we're at. Okay, because we're only going to load these images at certain breakpoints. So this code, what I've got highlighted in green, creates that watcher div, injects it into the document. Right? That's all you need to know. Then in the CSS, we used the font family property to store the name for each of the breakpoints. We created named breakpoints within our SAS files. So getActiveMQWatcher is the ID CSS selector. And then for each one, we had font family global, tiny, small, medium, large. It's really hard to name these things, right? Larger, full is our full width version. And then we had a method on the window object that we could use to retrieve what that value was. So window.getActiveMQ did a query against that CSS file and looked to see what the font family was that was being applied to that hidden div. Okay? So in use, what we were able to do is say, OK, the current media query is getActiveMQ, and then we would test to see, for instance, if it's larger and full. And if it's larger or full, then we go ahead and lazy load those images in. And that would take them from looking like this to looking like this. Okay, and I won't get in there. The data imaged equals true is there for CSS, and it's also there for JavaScript, so that the JavaScript doesn't try and load the image again, right? Oh, wait, we still want to optimize everything. So here we have Rachel's photo, right, which gets very blurry as we zoom in because we've got it fairly compressed. This was the original source file, which was still pretty small at 38K. It's not terrible as an image. We stripped away the color information. Una talked about that yesterday. That reduced it by 7%. We then cropped and resized it, got it down to a 12K image, 68% reduction. We then blurred and optimized it. So if you remember, Una yesterday talked about blurring as a way to improve or reduce the size of an image. So we used a technique that I think Jeremy came up with for a deconstruct site a number of years ago, where he blurred out everything but the faces. And he used like a feather mask in order to make the blur kind of spread nicely. But we basically went through and blurred everything but everybody's faces because our eyes are naturally drawn to faces. And so we don't even notice the blurring. And so we applied that to all of the images, and that was sort of our process. And then we also had the JPEG version, and then we had a WebP version that we created. So with the WebP version, we actually had a savings of 89% of the original file size, which was pretty awesome. Of course, not every browser supports WebP, again, as Una mentioned. And so we used the picture element to bring in the WebP version first. And it's important that you have the WebP version first because the first match wins in picture and video and so on and so forth. So always have your smallest file first. So first choice is WebP, and then we fall back to the JPEG if we don't have it. And interestingly, you can even take this many steps further. You could have SVG falling back to WebP, falling back to JPEGs. It's a contrived example, but you could do it. So instead of injecting the image element dynamically, we now inject the picture element dynamically. All right. So to summarize all of the various things that I have just covered, we should look for opportunities to use native features whenever possible. We should look to only include the assets that we actually need. Not things that we want, actually need. Optimize absolutely everything that we can in as many ways as we can. Think about when, during the loading process, we actually load our assets. And think about how we load those assets into the page. And then only add our assets when they actually add value. Every choice that we make affects our users' experiences. So let's spend our time in order to save it for our users, because speedy performance is a great user experience. Thank you all. And I think I've got about 7 minutes for questions, maybe. Anyone? No one? Everybody's brains are full, right? Yeah? All right. Well, thank you all very much. Feel free to hit me up afterwards. Thanks.